I watch a lot of trashy TV, and I don't just say that as a person who occasionally watches Maury when they are homesick, but as the sort of person who actively sought out tickets to see the Maury show as part of the live studio audience. Coincidentally, did you know that there is like a 3-month waiting period for those tickets? I guess part of the danger of it being free. Anyways, one of my favorite guilty television pleasures is Ancient Aliens on the History Channel, which, besides just being utterly fascinating, has some of my favorite television personalities, including Christopher Dunn, Giorgio Tsoukalos, David Childress, and the whole gang. So Christopher Dunn is a proponent of what is known as the Pyramid Power Theory. This says that the Great Pyramid at Giza was actually some manner of power-generating station. Now, whether that means it produced hydrogen gas for burning or caused microwaves to be emitted from the body of the pyramid. And he says that because of evidence that he claims to have found around the site of the pyramid, including machining marks and drill holes and just the general precision of the pyramid that he doesn't think can be explained by 1,000 slaves using the tools available to the Egyptians at the time. He says that these precise and difficult machining marks must have been caused by some advanced technology, and therefore we can infer that the ancient Egyptians must have had some sort of super advanced science that has been lost to modern historians. What is so fascinating about this theory isn't just the actual science of the thing itself, which I promise we will go into heavily in this episode, but also the storied history and continued use of the triangle and other geometric shapes as the crux of pseudoscientific or pseudo-historical beliefs. Just this past month, there was a story floating around about a kid who used Google Maps and satellite imagery of the stars to potentially find a lost Mayan temple, which he thought he had found by looking at a piece of forest that seemed to show a geometric shape that he didn't think could have been caused naturally. More recent reports have shown that a number of archaeologists are now walking back that claim. But still, it's an interesting case study. Going as far back as the beginnings of philosophical and scientific thought, we find whole religions and lifestyles centered around the perfection of geometry, and the particular fascination with the triangle, that most basic of shapes, from which all figures can be built using trigonometry and multiplication, is almost hardwired into our psyches. What is it about triangles that fascinates us, and how far does this triangularly shaped rabbit hole go?
Welcome to the Mad Scientist Podcast. Tonight's episode, Triangles, Ipso Facto, Aliens.
When I was an undergraduate student, one of the most fascinating things I learned in philosophy was the sort of things that scientists and mathematicians I used in my engineering courses had actually written or thought. And one of the wackiest by far was Pythagoras, who is famously remembered for his Pythagorean theorem, which says that in a right triangle, or a triangle that contains a side which is a 90-degree angle, which is the sort of side that a square has, the sum of the square of the longest side is equal to the addition of the squares of each of the other sides. This basic mathematical principle is the foundation of trigonometry, from which we can derive all higher mathematical systems, including differential calculus, and therefore is one of the linchpins of the modern world. We couldn't have physics as it stands now without this simple relationship found in the triangle, and one that was discovered back in the 500s BC. So Pythagoras is a pretty important guy, although it was only in later centuries that his mathematical thinking became the thing that he was most famous for. During his lifetime and in the centuries afterwards, he was most well known for his Symbola, or way of life, which prescribed different strict rules to his followers, as well as his metaphysical theories, which described what occurred to the soul after death. While some of his Symbola were strictly about religious things, for instance, he says, "Disbelieve nothing wonderful concerning the gods, nor concerning divine dogmas," he also said stuff like, "Cut not fire with a sword," and "Don't urinate facing the sun." So, all in all, a little bit of good and a little bit of insanity. After his death, his Pythagoreans, or the so-called Pythagoreans, as Aristotle described them in the Metaphysics, continued to espouse his worldview, although some of the thinking was mixed in with the philosophy of Philolaus, and really what we know of Pythagoras himself is quite murky at best. Interestingly, while other Greek philosophers at the time believed the world to be constituted of combinations of the basic elements of wind, fire, earth, and water, the Pythagoreans believed that the universe was actually composed of numbers. In particular, they thought that the properties of numbers, for instance evenness and oddness, could be used to describe and understand the natural world, and that harmony in these numerical qualities could lead to harmony in the universe. This is shown in what has now been called the Pythagoreans' table of opposites, where reality could be broken up into 10 distinct pairs. These are limit, unlimited, odd, even, unity, plurality, right, left, male, female, rest, motion, straight, crooked, light, dark, good, bad, and square, oblong. Notice here both that things were broken up into divisions, but a little bit of kind of a sociological question as well is the fact here that male and female are put down as opposites, with male being given good qualities such as light and good itself, while female was given qualities like crooked and darkness and bad. This happens a lot in the history of philosophy and the history of science, and even though there were female Pythagoreans at the time, it does start to hint at kind of a very interesting theme that I'm sure will come up more and more in these podcasts. Pythagoreanism as a religious cult lost its prominence over time, but this way of thinking about the universe and numbers is still very powerful. As a practicing scientist, it's hard for me to not see numbers and symbols in the everyday world. Everything out there can, for the most part, be described using mathematics, and sometimes in uncanny ways. The same mathematics that can be used to describe the metabolism of our bodies can also be used to describe the flight of a baseball through the air, and some mathematical rules seem as if they are universal laws. This has led to a number of scientists and mathematicians positing things like the unified theory, where both quantum mechanics and relativity can be brought together under the same mathematical umbrella. We've also used math as a universal language of sorts, and in fact, some of the most basic communication methods out there, and the ones that we are currently beaming into space in the hopes of communicating with extraterrestrial life, are composed of a binary mathematical language. Now, whether mathematics is merely a tool used to describe the universe, or an actual part of the fabric of the cosmos, is a question for another episode. But I always found the views of the Pythagoreans compelling simply because of the sheer amount of numerical language and thinking that goes on in my everyday life. I also am always very careful to never pee directly into the sun, so all in all, I'd say I am a pretty good practicing Pythagorean. Triangles are an interesting shape because they are the most basic figure that can be made in two-dimensional space. If we think of a point as sort of the building block of the one-dimensional world, and a line as the building block of the two-dimensional world, then a triangle is the fundamental figure of three-dimensional space. Every shape can be built from triangles, including circles and spheres through trigonometry. And it is this basic character and ubiquitousness of the triangle that makes it such rich fodder for pseudoscientific claims. The triangle and the number pi, that favorite of amateur pyramidologists and Egyptologists, are interconnected, as are all shapes, by a somewhat complicated mathematical rule that I would be insane to try and explain here. But basically, since the number pi is related to the circumference, or the length of the outside of a circle, and the diameter of the circle, by the formula pi times diameter equals circumference, and a circle can be drawn inside of a triangle with equal sides, then we can get pi from some pretty simple mathematical relations between the sides of the triangle, the diameter of the circle, and practically any combination of those things. In other words, with enough elbow grease, it is possible to finagle pi out of almost any two shapes that we put together. Even more comically, it is thought that the ancient Egyptians actually used circular measuring wheels to plan out the lengths of the pyramids, with a certain number of circular wheels being the size of each of the bottom lengths. In other words, if you were to take a circular wheel now and mark the top with a marker, and then push it along the floor until the marker point showed up at exactly the place where you had started, you would basically transpose the length of the outside of the circle onto the floor. So the length that that circle moved was how big the circumference of that circle was. So that's basically what the ancient Egyptians did. They measured out these circular measuring tools, and then they pushed them for a certain number of spins around the wheel until they got to the number that they wanted and called that one end of the pyramid, and then did it for the other end, and then started building from there. And what mathematically important number is particularly important when transposing the straight line length of a circle's outer surface, also known as the circumference? That's right, it's pi! So in reality, it could be the choice to use the circular measuring device that day versus the straight ruler that spawns a whole world of mathematical confusion and mystification. This is really important for pyramidology, where the exactness and geometric relations between the shapes that make up the pyramid are used as proof of some higher learning that was had by the ancient Egyptians. But believe me, if given enough time and resources, anyone listening to this podcast could come up with pi, or a multiple of pi, from almost every single geometric shape that they come up with in their everyday lives. Other sorts of geometric bunk are used all the time to put forward aliens or conspiracies, and all kinds of other wacky things. Again, I can't say that aliens don't exist, or that they are unlikely. Although again, that's a topic for another episode, so I don't mean to sound dismissive. But a lot of this sort of stuff, while not mere coincidence, does I think come from a general misunderstanding of the very basic character of geometry and its relationship to the natural world. One of my favorite sorts of theories like this, and one that comes into the pyramid power theorem, is that of the world grid, discussed by people like David Childress. I want to say that although I don't agree with Mr. Childress here, I do have a lot of respect for his continued quest for the truth of ancient history, and although our methods and conclusions may be different, I hope that if he ever hears this, he doesn't take anything too personally. I grew up reading the books of authors like von Daniken, and seeing these topics continue to be in the public sphere is at least, I think, a worthwhile endeavor that he's taken on. So alright, Mr. Childress is a proponent of a theory that is known as the Earth Energy Grid, one that posits that the great ancient sites of the Earth are laid out on a geometric grid-like pattern, over which aliens could potentially gather energy for their spaceships or for some other use. Childress says in the intro to his book, Anti-Gravity in the World Grid, quote, "However, the familiar image of the Earth as a globe girded in a lattice of longitude and latitude lines helps us understand what an Earth grid, based on more primary energy lines, might be like. I say energy lines particularly, because one of the most consistent observations readers will encounter in this book is that the geometric pattern of the Earth grid is energetic in nature, and that this Earth energy, organized into a precise web, was once, and can be again, the source of a free and inexhaustible supply of power, once empowering older civilizations of high technological achievement. Most grid theorists state confidently that this grid technology can be reclaimed again today. Despite the issue of where does this energy come from, or how can an object produce energy without losing that energy when it is transferred, and other basic physics problems with this theory, the mathematical issue is simply that the sorts of patterns they are looking for are found literally everywhere in nature. When I watch the episodes specifically on the Earth grid, Katie and I always end up ripping out our hair, because they'll point out that 3 points on a map can be roughly approximated to be on a linear path with each other, and then make all kinds of outlandish claims based on that conclusion. Even worse is when it is between 2 points, and they suppose that a third, more ancient, or even Atlantean, site must exist at this final place. Geometry and patterns in nature are commonplace specifically because they are often the least energetically difficult sort of configuration to make. Nature generally is quite lazy, and tries to keep things in as easy or low energy a configuration as possible. And it just so happens that geometric shapes with regular patterns happen to be energetically less intensive than randomly oriented shapes or behaviors. For instance, in chemistry, the hexagon is the single most stable shape possible for an organic molecule to take on, with 6 carbons bridged together into a hexagonal shape, making up a huge number of biologically important molecules. This is because in that configuration, the electron clouds of each carbon atom, which will repel each other due to magnetic interactions, are as far apart as they can happily be while still filling in as much space as possible. This is sort of like filling in a vase with marbles. The marbles, if given enough time, will settle down into the vase in such a way that the most amount of marbles can fit in, based on how close they can actually get to each other, while still filling in as much of the empty space of the vase as possible. But the fact that hexagons show up in nature does not require a secondary force that must have placed it there. The same thing is used when trying to fit the patterns of stars to the patterns of ancient sites. While I do think that the Orion theory is interesting, the Orion theory being one that states that the ancient pyramids of Giza were planned out in such a way that their positions with each other would approximate the positions of the stars in Orion's belt in the sky, I also don't find it hard to see that, again, given enough time and the desire to find a pattern in the stars that corresponds to the patterns we see on Earth, that we probably could. Finding patterns is simply in our nature, and geometry provides a catchy method by which to address those patterns. As Michael Shermer, a personal hero of mine, says, quote, "Humans are pattern-seeking, storytelling animals, and we are quite adept at telling stories about patterns, whether they exist or not." And just a general question for those that subscribe to the ancient alien theory, and again, I don't have any particular issue with the idea that potentially we were visited by aliens in the distant past. But where does this line of thinking end? It seems like an infinitely regressive argument, one that continuously requires another, more advanced civilization to explain the thinking and powers of the civilization that comes next. If aliens helped us start technology, then did aliens help the aliens? And so on and so forth until infinity. One of my favorite podcasts of all time is The Ricky Gervais Show. And in it, Carl Pilkington had a hilarious thought on this sort of thinking. He says something about computers being composed of sand. In other words, computer chips being composed of silicon dioxide. He states that it's so hard for him to get his mind around that thought that it must have been an alien that helped to make computer chips. And he says that the reason he thinks that is that computer chips are just so much more complex than other inventions like the Frisbee, or his favorite invention of all time, the Dyson vacuum, or as he says, Dyson vac. But as a scientist and working in new technologies, I promise that the inventions that will change the world 50 years from now have about 1,000 graduate students working on them right at this instant. And each of those graduate students are probably working on an extremely small part of the problem that will only become part of a larger, grand solution when some genius who's there at the right place and right time will see these threads all coming together and put them into one thing. I mean, for instance, I have one friend who I hope to interview here soon for an episode on anti-cancer myths. And not to oversimplify his work too much, but he's basically taking cancer cells and electrocuting them, and then seeing if they'll bounce off of other cancer cells or off of healthy cells. And who knows, one day Mark's work could very well be the linchpin that solves the problem of metastatic cancer, but at the ground level, from where the individual researcher is doing stuff now, it is only a very small part of a larger whole. In this way, big scientific discoveries are much more like 1,000 people pushing a stone block 1 foot than a single person pushing that same stone block 1,000 feet. Change is incremental. And because of that, big changes might seem to take place right away from the person who's buying the materials or the inventions out there in the free market. But at the scientific side, studies and information that leads to a big invention have been being accumulated over centuries. So I've gotten pretty far off topic, but I hope into some interesting territory. Now for the meat of the thing, pyramid power theories. Pyramids and geometry in general clearly have a very interesting place in our consciousness and collective history, and I hope I've outlined some of that in the preceding sections enough that maybe you're interested to learn more. If you are, please send me an email, and I could always do another episode on this stuff. I can talk about pyramids and mathematics and just general mathematical phooey all day. The pyramid power theory takes some of the geometric thinking and puts it together with another interesting theory, one that we've hinted on already, that of ancient technologies belonging to the Egyptians and other ancient cultures. One example of this that's often cited is the discovery of the Baghdad battery, which, although it sounds very interesting, is the equivalent of a third-grade science experiment. I was fascinated with this thing once I first read about it as a kid, and was pretty disappointed to learn that I could get the same voltage with some materials that I had in my fridge. The basic premise of the pyramid power theories is that the Great Pyramid at Giza is so different from the others found at the site that it must have had a different purpose. Furthermore, the sorts of channels and things found in the pyramid that we can't quite explain with normal archaeology must have had some secondary purpose that we cannot understand. Furthermore, some of the machining and tooling marks found at the pyramid site can't be explained if we use traditional thinking about the knowledge that the ancient Egyptians had. Now, I'm not interested in putting pyramids over my old food, as suggested by Antoine Bovis, who thought that they could help to keep meat products from spoiling. I'm also not particularly interested in discussing the idea that pyramids can heal cancer, help with your brain power, make plants grow more quickly, or any of the other wacky sorts of ideas proposed by pyramid fanatics over the years. The fact that these things are just so prevalent is a little bit strange, but it does show how readily humans jump to believe in these sorts of paranormal-ish and pseudo-scientific beliefs. The pyramids are awe-inspiring, and it's crazy to think that basic human tools could be used to construct it. But that doesn't mean that they are magic in any sort of important or special way, and if they are, then we have to open a whole other can of worms, and also start walking around with pyramids on our heads. For this episode, I am interested in the work of Christopher Dunn, who has done a lot of work on the machining and techniques used by the Egyptians in constructing the pyramid. Again, just as with David Childress, I hope I'm not giving any offense. And although I don't agree with Mr. Dunn in his conclusions, I do think a lot of his work is really cool. His general thinking is, from what I can tell, that the Great Pyramid acted as some sort of energy generating station. This is supposed to work as water fills in the channels below the pyramid's main chamber, which as the Nile ebbs and flows causes vibrations in the walls of the pyramid, the energy of which is then transposed through the body of the pyramid to the granite walls that are there. The granite will then shoot out ions, negatively or positively charged atoms, to the surrounding air. The air inside the pyramid is filled with hydrogen gas. The hydrogen is then stripped of its electrons, resulting in a proton laser beam that shoots from the tip. Okay, so a lot of things to go over here. The most basic one is probably, how are atoms constituted? Atoms are composed of a nucleus, composed of protons which are positively charged, and neutrons that are neutral but add weight to the atom. And then this nucleus is surrounded by a negatively charged electron cloud. Now, when these electrons are whizzing around the nucleus, they're not whizzing around in purely random order. Although an electron can technically be anywhere at any given point, the electron is whizzing around in such a way that they will be constricted to these zones of most probable position, so areas where they're most probably going to be found, that we call orbitals. Now, these orbitals are arranged in such a way that nearest the nucleus, the electrons are very, very hard to move out of that orbital, whereas the orbitals farthest away from the nucleus have electrons that are very easy to remove. Since electrons are negative and the nucleus is positive, the electrons and nucleus are attracted to each other, and therefore it's harder to remove any electrons from closer to the nucleus than from the orbitals that are farther away. Now, an important property of atoms and of electrons in general is that you can actually add energy to an atom to make an electron jump from a lower orbital to a higher orbital. This is called excitation. We can do this by, for instance, adding light or a photon to an atom. So you shoot a photon at an atom, an electron is excited from a lower orbital to a higher orbital, and then over time, that electron will relax again because nature is very, very lazy and doesn't like things to stay excited. When that electron is de-excited, the atom will actually release the photon that it initially absorbed. So you can sort of think of it as, me and you are in a room. You give me $1, and for a little bit, I'm very excited because I have an extra $1. And so I'm floating around the room. But after a little bit, I give you your $1 back, or it flies away from my pocket or something, and I go back to my initial depressed, dollarless state. Alright, so we've gone over some of the basics of atoms and atomic structure. Well, what is a laser then? Laser stands for light amplification by stimulated emission of radiation. A laser works because of the ability of molecules to absorb and desorb photons through optical stimulation, like I just described previously. Basically, we supply a photon to a given material, which is absorbed by the material, causing it to go into an excited or high energy state. After a given amount of time, the material will relax again, releasing the absorbed photon. Now, usually, these releases are in random directions. However, in the case of lasers, some of these photons will hit another atom in the same material from which it was initially desorbed. This creates an amplification of the emission, going from a net 1 photon released to 2. And with enough of this amplification, we can obtain the very high beam strengths found in modern lasers. By then playing around with the rate and energy of photons added, and the types of materials that are doing the photon emission, we can get different colors or beam strengths. Clearly this laser thing is pretty complicated, but to make one you really just need a consistent photon source, which in the case of modern lasers is a flash tube that cycles on and off with a lot of light after being supplied with high voltage, a material that can amplify photons, which in the case again of modern lasers we use things like special types of metals or ruby or organic dyes. And then you also need a series of mirrors or other materials that can basically streamline the photon beam into one direction, creating a laser beam. Now, based on Dunn's description, he is using the acoustic energy from the water pumping into the bottom of the pyramid to ionize the hydrogen gas in the pyramid body, which then relaxes and creates the laser beam. So, what is an ion? An ion is a case where the atom that has all those electron clouds floating around with it will either have an electron removed, making it positive, or an extra electron added, making it negative. Usually, in a happy atom, the amount of protons and electrons found inside of it will be equal, so that the charge that's negative will completely balance out the charge that's positive. Some atoms can become ionized more readily than others, and that's because they might have a lot of electrons in an orbital state that's pretty far away from the nucleus, but not enough to kind of minimize the energy that the atom will feel from these negative electrons floating around outside in this outer shell. So for instance, metals, such as sodium or potassium, or halogens, such as chlorine or fluorine, have this sort of situation, and so these things can become ionized pretty easily. And that's why, for instance, sodium chloride or table salt will just dissolve right away in water. What's actually happening there is the ions are breaking apart readily. Just because some things can ionize pretty easily doesn't mean that the air, for instance, could ionize readily. In fact, the air ionizing is really rare, and it takes in a tremendous amount of energy. That's because the air is composed of very stable molecules, such as oxygen or O2, nitrogen or N2, and then things like argon or xenon. And because of this, to think that the energy being transported through the pyramids from the water flowing could possibly be enough to ionize the air just doesn't really add up. Besides the problems with, well, how much energy really comes from the water, and how is it being transported actually through the pyramid body, and what does it mean, like why do the granite walls really matter? I guess potentially granite is radioactive somewhat. That's why in places like New Hampshire you can actually measure radioactivity. Every piece of granite has a small amount of uranium inside of it, but not enough to hurt you in any sort of way. But still, this idea of the granite having enough energy or enough potential to actually ionize the air is pretty crazy. The only time in nature normally that any of us would see air being ionized in that way is during a lightning strike. And that happens so rarely simply because it takes so much energy to cause a lightning bolt to occur. When a lightning bolt hits the earth, what's happening is the air is being ionized in a path. That path is then having electricity shot through it, and the bright flash we see is actually those electrons being stripped and then put back down to their lowest energy levels. We're basically creating a plasma stream there. Plasma being this sort of electrified and very excited form of gaseous matter. So all in all, I would say that this first theory doesn't make a whole lot of sense, simply because it takes so much energy to actually ionize air that there is almost no feasible way that that could happen from the setup that he's saying. And again, that's even giving this idea that the water from the pyramid could supply any power, any credence at all. Now, a different version of this theory that I've read that is also attributed to Mr. Dunn, but potentially I've gotten that one wrong, is that the pyramids act as more of a modern-day hydrogen fluoride laser. In this system, a chemical reaction first occurs where two fuels are burned together, generating a special kind of chemical known as a free radical. Now, a free radical is the case where the electrons in that electron cloud have only one electron removed at once. Usually on a molecule, you like to remove two electrons. This is because electrons sit in things called pairs. This is again done by nature because it's lazy and it likes things to be as stable as possible. However, if we remove a single electron from a molecule, we end up with a radical. Now, a free radical is an extremely reactive species that will almost immediately try to find something else to bond with. When you're creating a chemical laser, you are burning fuel in such a way that you generate one of these radical species consistently and in high amounts. When the radical is created, it will react with the gas that is going to be doing the laser emission by bonding to the gas species and creating an excited gaseous molecule. The gas is then relaxed and normal laser emission occurs. If this was how the pyramid was generating a laser beam, it gets rid of the problem of the energy source, but requires the ancient Egyptians to have access to extremely reactive chemicals and the ability to move them about and use them successfully. Not only that, but it would require a comically large amount of hydrogen gas, something that besides being explosive, which Dunn actually thinks may have caused some of the scorch marks that he sees inside of the pyramids, it would be pretty hard to pressurize and transport all that gas in such a way that we would not be able to tell that they could do it at the time. Besides that, if they were able to transport gases in that technologically advanced way, then why did they not simply do that with the waters of the Nile to stop drought and the subsequent famine? So the whole laser thing, I think, doesn't make a whole lot of sense. Besides there being no evidence of an optical tuning method that would change the random laser photons into a beam that could be harnessed, there is no evidence that the Egyptians could actually transport gases in the way described, besides the lack of a really sensible chemical source for the chemical laser method, or a significant energy transfer method for the water acoustic theory. So alright, we've gone through a lot of the science this time, but why do we expect these pyramids or the people who built them to be all that advanced or important anyways? I guess a big part of this would be that the pyramids are pretty magnificent, and it boggles the mind of many how they could possibly have been constructed without the use of advanced technologies. But the fact of the matter is that they had all of the tools needed to move giant stones and carve them at the time, and anyone who has had to move a refrigerator knows at least one way that this may have worked. The same principles of rocking a large object back and forth on a lever arm to cause it to move small distances in a way that kind of looks like it's walking is a time-tested method that works even for giant objects, without the need of UFOs or anti-gravity beams or giants or any other esoteric methodology. If you have some free time after listening to this episode, I highly suggest you look up on YouTube the video titled "Man Moves Huge Blocks," which shows these principles in practice, and also is up on our Facebook page. A single person moves blocks the size of those found at Stonehenge, and all it takes is a little bit of physics. And the Egyptians had thousands of workers and all the time in the world to use on these projects. I also think that some of these ancient alien or ancient pyramids being constructed with advanced technologies theories really takes away a lot of the prowess or takes away a lot from our ancient ancestors. Humans are an intelligent ape, basically, and the fact that we could build something like the pyramids is awe-inspiring. It is absolutely amazing. And to say that we needed aliens, I think, besides being an infinitely regressive argument, like I said before, doesn't give human beings enough credit. That's it for today's episode. Thank you for joining me here on the Mad Scientist podcast. I'm your host, Chris Cogswell. I hope you'll be able to join me for the next episode, which I hope to put out in about 2 weeks. I want to make these things a little bit more substantial than they've been, and hopefully giving myself 2 weeks as opposed to 1 will allow me to really research these things a little bit more in depth and provide a lot of very interesting knowledge to you guys. Thanks again.